Hello everyone, this is Chris Paap from Platform9. Today I'm going to walk through deploying a bare metal cluster using Ironic. In that process, we're going to boot Ubuntu, we're going to pixie boot it, come all the way up, and then we're going to use the Platform9 API to create an empty cluster, and then we're going to then add those nodes to the cluster as part of that deployment process without having to manually go into the management plane and add those manually through the control plane. We'll just go through and we'll add that as part of the deployment process. And then once that's done, we are going to go through the process of actually upgrading this cluster to the next version of Kubernetes. So we're going to walk through the UI and see what we have here. What we have is a single Ironic conductor. So this Ironic conductor is placed in your location. It could be a VM, it could be a physical host. In this case, you want it sitting close to where you're deploying your images to that environment. So all you need is one per environment. Our bare metal nodes are actually our BMC, our bare metal controllers. Ironic communicates with those bare metal controllers via IPMI 2.0. One of the requirements that we have is that it sets up a provisioning network, and that provisioning network not have DHCP on it. So we're going to go in here and deploy. We're going to choose this focal server image, Ubuntu 2004. Hit next. This is the flavor that we have. The VM we're going to choose. This is the provisioning network that's allocated. We're going to call this node-01, and we're going to add an SSH key here. Now this next portion is where it's very important that we do this, that we actually check yes to a configuration drive. And I'm going to copy and paste a CloudNet script here that will both create the empty cluster called cluster01, and then it's going to download the Platform9 agent, initialize it, and have it communicate to that newly formed cluster. And then it's going using the Platform9 API, and then it's going to install that agent on there, and then install that node into the management plane automatically. If you look at this, this is a cloud config. It'll run this registered node sh after it's done. Here are all the configurations for the cluster. And then you can notice this is where it downloads the agent and runs through the config set prep node and attach node. We're going to hit finish. Once we go create, it's actually going to kick the process off. It's going to communicate to that bare metal controller. In fact, if we go back up here, we'll be able to see that it actually grabbed one of these bare metal controllers that were available, and it's assigned it an instance UUID. So if we go back here, what it's going to do now, it's going to connect to it. It's going to pixie boot that host, and as it pixie boots that host, it's going to apply that image, and you'll see this eventually come up with an IP address, and it'll boot all the way up, and then when it's done booting all the way, it'll kick off that CloudNet script. Okay, so we see that the node has gotten to a point that it has an IP address. It's still provisioning, it's kicking off, still different tasks on the server. Let's go look at the management plane. You'll notice that we are on the sc.platform9.io management plane. So you have different clusters here. At the very bottom, you see cluster01 was created. It's an empty cluster. It's in a healthy state because there are no nodes attached to it. There's no master node, no worker nodes. As this boots up, you're going to see this area populate with a node 01. So let's go see where the status is of that node. Node health. It's on step 2 of 20. It's preparing the configuration. Next up, we'll go through configure runtime, start container runtime, configure etcd, start etcd, etc. So as it goes through that process, we get all the way down to 20. Once it gets down to 20, it'll complete successfully. And the API server, all the Kubernetes services will be up and running, and at which point we can add the worker node. So while that's going, let's go ahead and kick off the worker node. We're going in parallel. So same thing, same process, bare metal node, local server, SC flavor, provisioning, everything's all the same. We'll just call this node 02. And configuration drive, and we'll add the worker script on here where it's just making sure that there is a worker, there is a cluster called cluster01 to be added as worker it'll install the agent and look for that cluster, and then add that node once the agent is installed to the cluster. Well, that's going. Let's check out cluster 01. Looks like it's in a healthy state. If we look at it, yeah, node 01 is completely added. We'll go through the steps. It went from, last time we looked at it, it was preparing configuration. It ran all the way through down to configure and start monitoring. So we have a single node master called cluster 01 with Kubernetes 1.25.15 deployed on it. And we'll start seeing a worker node pop up that will be added to that as well. We'll have a 2-node cluster, 1 worker, 1 master. Okay, we're seeing the screen refresh with node 02 now showing up successfully. So now we have a healthy cluster sitting at 1.25 with a single master and single worker node. So what we're going to do is let's go back out and managed. We want to see here, let's look at the options. So if we go here, we know we can upgrade. And it gives us the opportunity to do a minor upgrade to 1.26.10. We have 2 upgrade strategies. One is sequential, so it'll do 1 node at a time. The other option, if you have a very large worker environment, GPU worker environment, so you have 100 nodes, you can set a percentage of how many nodes you want to upgrade in parallel. Now, there is a third option that we can do. That is via the API. The API will allow us to grab a token and then select that cluster and get information about that cluster, and then select a specific node to upgrade at that time, or what we call batch. So every time you want to select a group of nodes that are available, if you have long-running jobs, you can select a single node to do that, or a group of nodes. Say there's 10 that are available to upgrade at the time, you can do that as well. So and there you can pause that after a while as well. So if you are running long tail upgrade jobs where you're waiting for these pods that may be running for a week or multiple weeks at a time, and you can't upgrade that node until that job is finished, then you can keep that in that mixed state until that occurs. It won't fail out, you won't get any errors, and that's the point of using the API. It gives you some granularity of being able to do that. Okay, now that this is coming up, let's jump into a terminal and run some API commands to get the information we need before we start the cluster upgrade. So first we need to get a token. I have the command here that I'll paste in. So this is the management plane with the keystone /v3/auth/tokens. It has username and password information and the scope, what we're going to get. So it'll actually export this token and save it. We're then going to get the name and UID of the cluster 01 that we'll need. So if we do that, we'll get the UID and the cluster name. We can also get cluster details from the API as well. So if we type the following command in, you'll see that you noticed this is the UID of the cluster. I have the UID here as well. If we type that in, we'll get the name, upgrade, the current version that it's on, and the version we can upgrade to 1.26.10 as a minor upgrade. So while we're getting information via the API about the cluster prior to the upgrade, I kicked off a deployment for a spared node to have to bring a node into the cluster to offset having a node go down during the upgrade and when it comes back up. So the idea is to bring a new node in, upgrade that node, and then drain the existing node of any deployments, any jobs, have them come up on the newly added node, that's the hot spare, and then upgrade the other node before moving on. And then having those that were migrated over, having those pods, having those deployments, then drain them back, evict those pods back over to the existing, the original node that they were on. So if we look at the infrastructure tab, you'll notice that we have this upgrade node. It's healthy. It's been added. We'll go in here into Kubernetes. We'll look under workloads and look at deployments. You'll notice that this Nginx deployment was the application that was deployed as part of the automated deployment that we kicked off when we created the cluster. If we look at the pods associated to it, all the pods are on 192.168.50.249. Those pods are, when you look at them, are actually this node 2. They're all on 249. So if we go back into infrastructure, cluster 01, node 2, 50.249. So we're going to upgrade this node and the master node as part of the batch process, and then migrate or evict those pods over to node, to the upgrade dash node. And then we're going to upgrade node 2 and then evict these pods back over to node 2 to where they originally started. Okay, one of the things we're going to need to know before we upgrade this node is we need to make sure we get this unique ID to identify this node. And we're going to put in the command to upgrade that particular node. So with the API, it's called the API batch upgrade. By default, it upgrades all master servers in that cluster. So if there's a single master, there's no need to call that out. It'll upgrade the master first. And then in the batch upgrade nodes, which you see right on the end here, that's where you enter the unique ID. And this is where it gets updated to actually go through the process to upgrade that particular node and only that node first. So since that node is empty, we just brought it in the environment, there's no workloads running on it, I'm going to go ahead and kick this off. So it's running as OK. So you'll notice that we are now at 1.26.10, pmk.92, and the master is upgraded to that. We still have not upgraded node 2, which has our deployment on it. Of Nginx. You'll see the pods here. So something I want to point out is how we're going to make sure that this fails over, or when we evict this one before we upgrade it, that it goes to the correct node, especially in a cluster where you could have hundreds of nodes. Let's go into the YAML. And where we can look for this is actually, let's do a zone US West. So this is a label that we assigned to these pods of zone US West. So any node that we want to fail over to this needs to have that label zone US-West. Another way that you could do this as well is in the node label you could set up, or in here you could also set up node affinity to set up specifically to only reside on certain nodes. So different ways you can do this, all done by labels, fairly simply. So what we are going to do is we are going to drain node 2, which is 50.249. And it's going to make sure that those 3 pods that make up Nginx is going to show up on .26. Because if you look at, nodes, you actually look at, let's say, it's actually kubectl describe nodes. You'll notice that the label actually has zone assigned to it, zone-US West. So it should fail over. So let's go ahead and drain that. So it's going to be kubectl drain been cordoned. You'll see it's evicting pods. As it's going through that process, let's go to infrastructure. You'll notice that it should show up under the cluster after we refresh. It'll show up as scheduling disabled. So it's been cordoned off, and those pods should be failing over. Let's go to Kubernetes, and let's go to workloads, deployments. Pods, and 51.26. We go back to infrastructure, clusters. 51.26 is the upgrade node, so it's running on the correct node. There's a unique ID. Should be back in OK status. There's the OK status. We should see this start to, okay, now you see it upgraded. 1.26, so this whole cluster now is at 1.26.10. All three nodes show at 1.26.10. Still showing scheduling disabled, so what we'll do is now we will uncordon off. Okay, so it shows it is healthy. And so what we'll do now is we will drain the upgrade node. So the pods are evicted and they come up on the original node. All right, it's evicting. You see the scheduling disabled. Let's go to Kubernetes. Let's just go to unselect. We'll just select default. Go to workloads. There's the deployment. It's still there. Give it a second. Do a refresh. Now we got it. Now it's showing up at 249. And 249. So they're back to the original host that they were at before. So now what we've done is we've created a cluster using the ironic to go from bare OS to cluster creation via the API and adding the worker and the master to that pre-existing empty cluster. We then added a spare upgrade node and had all pods on the node 2 worker evict to that upgrade node after the master and the upgrade node were upgraded. And then we then upgraded the original node 02 and then failed or evicted the jobs pods back to 02. So they're back to where they were before, except now it's on an updated Kubernetes version of 1.26. If you have any questions, feel free to reach out to support or check out platform9.com/docs, where we have the API information on how to upgrade, batch upgrade via the API. Thank you.